The next assembly we're going to discuss from FebCO is the model 860 and 880 series. These are reduced pressure principal assemblies. Production began around 1997. The 860 in the horizontal configuration goes from 1/2 inch all the way to 10 inch. The 880 has the up and down piping configuration as we saw in the 870 double checks, and that's produced in sizes 2.5 through 10. So the smaller sizes, 1/2 through 2, let's discuss the 860 first on the small sizes. Here's a picture of what that 860 is going to look like in the small sizes. Inlet shutoff, outlet shutoff, single access for both checks from the top. Relief valve is disassembled from the bottom for the average repair. Here's a line drawing of the internals. First check, second check, and relief valve of the model 860. Again, produced in sizes 1/2 through 2. Checks are inline construction design, modular in construction. Single access cover on the top is removed, and the checks come out from the top, similar as we saw in the 850 double check. Relief valve has a relief valve cover on the bottom for disassemble of the stem, removed out for a repair. The larger model 860 in the 2.5 through 10 inch, inlet, outlet, shutoff valves, horizontal piping of the check assemblies, first check, second check cover, checks, springs are retained for the average repair. Relief valve is mounted underneath. The relief valve body stays attached to the check body for the average repair. Removing the cover allows you to get access to the relief valve. Here's a schematic of the 860 showing the internal parts. First check, second check, and relief valve mounted underneath. Checks similar as we saw in the 850, difference being the spring loads of an RP versus a double check, of course. Repair checks from the top. Covers come off. Check springs are contained for the average repair. Relief valve cover comes off here. Stem assembly is removed for the average repair. That's the 860 horizontal pattern RP. Here's the 880 series with that end pattern up and down piping configuration. Here's the 880V as in vertical. First check coming in like this, going sideways, and the second check being rotated on that groove coupling rotates the second check 180 degrees straight up as opposed to straight down, giving it a vertical orientation. Here's that valve setter again, as we discussed earlier, to maintain that center-to-center pipe difference if you're cutting this valve into a piping system. Here's the model 880 showing the first check and second check. First check cover comes out from the top, second check cover to the side. Gives it that N pattern, or that small installation pattern as it's installed. Here's the relief valve cover. When the cover comes off, here's what the relief valve stem looks like inside that. So that's the 880 series, and the 880V is when they take the groove coupling at the end of the first check body and rotate the second check 180 degrees so that it's pointing up instead of straight down. They do produce a reduced pressure detector assembly version, the 866, which is the horizontal piped 860 with the bypass, and the 880 versions, which are the 886 and 886V RP detector assemblies. So we've got the 850 in sizes 1/2 through 2 in the small sizes. We have 850 in sizes 2.5 through 10 in the larger sizes in the horizontal configuration. 870 is going to be our double check in the end pattern or up and down configuration. 860 is our straight pattern RP. 880 is our end or up and down pattern RP. So those are what they call their master series of assemblies. So we're going to go ahead and take the assembly apart. Let's take a look at it now. Now let's do the relief valve from the models 860 and 880. The 860 being the horizontal series as we looked at, and the 880 the up and down configuration. The relief valve on both of them mounts underneath, and there will be a flange on the back side that holds the relief valve seat, back of the relief valve seat like this, and then this version being with the relief valve sensing line coming through the body. Depending whether it's the 860 or 880, it'll either attach here or there'll be a fitting on the side that it'll attach through a sensing line. But anyway, taking the relief valve off of the body for the repair. The YD, we left the relief valve body on there. This one, taking the bolts off, might make it a little bit easier to remove it, to repair it. Go ahead and remove our relief valve cover bolts. Notice we don't have the issues with the casting marks that had wrong model number designations on it. So let's go ahead and remove our relief valve cover bolts. Once we remove our relief valve cover bolts, we're going to see that same looking rolling diaphragm that we saw in the 825 YD series, and under there we're going to have that same tag that tells us do not twist, push straight in. We talked about with the rolling diaphragm in the 825 YD series. To remove screw, cut tab and lift center circle, same thing. We're going to remove our tab to get at that screw. Once we get at that, the whole stem assembly will come out in one piece. Now, it's a little different looking so far because remember on the YD series, this was made out of stainless steel. Well, it wasn't changed to plastic to save 2 cents or whatever, but the point is this is a whole different type of mechanism than what we saw in the YD. Remember in the 825 YD when we looked at the relief valve, we said the high pressure sensing line came in the cover just like it does on this version. But if you remember over here there was a hole in the side of the body where our low pressure sensing line came through. You'll see here there's no low pressure sensing line coming through the body. So where is this mean it's not hydraulically balanced? No, it is hydraulically balanced. But where our relief valve sensing line this time comes through is in the center of our relief valve stem. See the hole drilled through the stem? That stem hole goes all the way through the stem, through the guide the disc holder guide here, travels through the center of the stem, and actually comes out this upside here. So we'll show you when we get this apart. So there is no low pressure sensing line in the body this time. It's actually through the center of the stem mechanism. So let's go ahead and take this apart. First thing we have to unscrew is the relief valve disc retainer slash guide. This is how it slides in and out of that bushing in the seat. Once I have that apart, I can turn it over, remove my screw, just like with the 825 YD series. Once I remove that screw, there will be spring tension from the relief valve underneath. So I want my relief valve spring with this assembly bolt, which we'll talk about in a minute. Notice this funny looking little white washer here. That was not under the other one, was on the YD. This is called a diffuser plate, and we'll talk about that in a second. Relief valve spring. Once I get the relief valve spring out, I have my relief valve stem. I have that same looking stationary guide that we saw in the YD series with the lock nut holding my lower rolling diaphragm in place. Lower rolling diaphragm, friction washer, and stationary guide O-ring. Very similar parts as we saw in the YD, isn't it? A few little differences. But as I mentioned earlier, the main thing to notice is that stem is hollow. So that means our low pressure sensing line, the water travels through the stem. That stem is attached to this, the guide is attached to that stem, and the water travels through the center here. So how is it coming up water through the bottom, through here? What sits on top of here is our spring and spring retainer, if you remember. Well, if you take a look at this screw, you'll notice right dead center, there's a hole. And if you look on the side of the hole, there's a corresponding hole. So in other words, that water comes up through the center of that screw, through there, up through there, and then comes out this side on top of the retainer. Well, not actually out on top of the retainer, but it looks, because if you'll notice that it's just about 2 threads below the top. So it's sitting just a thread below the spring retainer. What was under there? That's that diffuser plate. Now that's why the diffuser plate's so important, because you'll notice on this side there are 4 little channels. On the other side it's perfectly flat. So it has to be up so the channels go against the spring retainer. What's happening is the bolt's coming down from the top through the spring retainer into the diffuser plate, and it sits just like that. And that small little hole is bringing my low pressure sensing line across these 4 lines on the outside underneath my spring retainer, which again gives me my low pressure relief valve loading on my relief valve. Very important that the diffuser plate be up. You can see if I put it on backwards that it almost covers that hole, which affects the openings of my relief valve. So be very careful when you put it back together. The diffuser plate is pushing straight up. So the channels will be pushing against that spring retainer. If I turn it over this way, it's wrong, and you can see I have no way to get water outside that channel. So why the diffuser plate? Well, the rationale behind that was that in the older series, the 825 YD series, if you remember, that relief valve stem looked the same, but the low pressure sensing line came through the body. So when the water came out of the body, it would fill this side first, and it had a tendency to cock the relief valve slightly from the side where it filled it. Water would come in and it would just kind of cock like this, which made the opening and closing of the relief valve a little just not as smooth as they wanted. So by putting the diffuser plate on the top like this, what it did is it caused the water to come out in 4 streams and more uniformly make the relief valve move through its travels.
Again, the relief valve high pressure sensing line closes it, but to open it with that 4 passageways made it so that it was more balanced in its opening was the rationale behind it. And reassembling, let's go ahead and put it back together now. We start with our stationary guide O-ring. We're going to take our rolling diaphragm, and our rolling diaphragm, the lower one, is directional. There is a rounded side on this lip, if you'll see right here. So the rounded side has to go into the recess inside our stationary guide. There's a flat side, and that side goes up, and that goes against our lock nut. And that's why we have a friction washer on there, so that it doesn't twist that rolling diaphragm. We've seen several rolling diaphragms already. We know the biggest problem with rolling diaphragms is twisting action. If it doesn't roll perfectly smooth in its travel, it will not work well. So how we're going to reassemble this is just like with the 825 YD relief valve. Go ahead and put the relief valve, the lower rolling diaphragm, in the retainer, making sure it's flat on top. Take your friction washer on the lock nut. Go ahead and tighten the lock nut. Remember, that roll will act as an O-ring, so hand tight is good enough. You don't need a big wrench to get down there. Now we're going to bend that rolling diaphragm back out in a cup shape, in the shape that it's going to travel in. And just like that. Once we have it rolled halfway up, we're going to take our stem and just kind of wiggle it back and forth till we get it in the center of that rolling diaphragm. Line up our bolt hole, press up on the stem, have it centered, and then make sure it rolls straight up and down like that. Once we've got the centered on our bolt on the top, go ahead and put our relief valve spring on top. Don't forget our diffuser plate that we're going to put on here next. Diffuser plate has to be pushing straight up with the lines up so that the spring retainer sinks against those, so that when the water comes out through that little screw, it goes along that diffuser plate. So push down, catch our assembly bolt, tighten it up. Now, just like with the YD series, when we get to the end of that tightening section, we want to hold both the stem, the guide, and the spring retainer. Holding all 3 pieces counter to the tightness of our screwdriver so we don't twist it. If we twist this at this point, that rolling diaphragm on the inside will be shortened in its travel and will affect the relief valve opening point. Then on the relief valve disc retainer / guide, again, not twisting is very important. Relief valve, we're ready to put that back in. Same problem with the YD where it's kind of a blind assembly. We've got to try to catch that in the very center. Use the relief valve discharge to help you, assist you as you see it go in. And that way you can make sure you get it right in the center. Remember, like all relief valves, we have to stroke it once to make sure that that O-ring on the stationary spacer isn't loaded. Don't push from the sides because it is possible to twist that. Push from the very center, making sure that you push and not twist it in any way. Our small little tab to cover up our screw. Our rolling diaphragm, line up the bolt holes. Do not twist the center trying to catch it. Relief valve cover, just like that. Again, critical thing is to not twist that smaller, meaning the little rolling diaphragm in the middle. And it's very easy to do, unfortunately, once you get it assembled, because you can't see when you cause that twisting action. And when you cause that twisting action on that rolling diaphragm, you shorten its travel, which will affect the relief valve opening point. And we don't want that. There is the relief valve assembly from the FebCo models 860 and 880 reduced pressure principal backflow prevention assemblies. We've looked at the relief valve that was in the models 860 and 880 Masters Series reduced pressure assemblies. And this was the relief valve that was used on that we just took apart up until January 4th, 2014, when the EPA decided to come up with a new definition of lead-free bronze. They changed the definition from a maximum of 8% to a maximum of 1/4% of the wetted area, which basically required the removal of either of bronze as we know it, meaning usual leaded bronze material, to a non-leaded bronze. And they tried some non-leaded bronze alloys, but Febco chose to go to a ductile iron body that's fused epoxy coated in their new lead-free versions. So the relief valve you see here on your left is what's going to appear on the LF models 860 and the LF models 880, and the corresponding RP detector assembly, which has an ST designation, 886 ST. So this is what we just saw. This is what you're going to see in the future. So let's go ahead and take them both apart at the same time to try to see a little of the changes that we've incorporated into the lead-free version. This one, relief valve cover bolts come off, which exposes our diaphragm. This cover comes off. Also exposes a diaphragm, which is different, a little different looking here, as we can see. So, diaphragm, flat gasket seal, diaphragm here, rolled slotted body here, so acts like an O-ring, makes it easier to seal. Check stems look the same at this point with those same instructions we're used to seeing. Do not twist, push straight in, push straight out again. Important to know that because we don't want to twist that rolling diaphragm inside. And there's the leaded version of that body. Check the relief valve seat on the leaded version, as we saw, is held in the backside by a 4-bolt flange. The ductile iron version, similar. It's a plastic seat held in by a 4-bolt flange. Stem assemblies. Again, taking them apart together so we can kind of see what they look like. Let's do the one we just did now. The old version first. We're going to take off our relief valve disc and relief valve disc retainer / guide. Notice that we went to a silicone rubber versus the black rubber, the butane nitrile type rubbers. Notice that our guide surface here, that's the relief valve guide for that mechanism. Remember the stem moves in and out like that, was bronze in the old version. The new version's plastic, which makes a little sense since we have to be lead free now. Going to remove this spring retainer screw on the top, so there will be spring tension from the relief valve underneath. I'll do the same on the old version. Same story. Will be spring tension underneath. Once the spring retainers come off, we will see the diffuser plate, which we talked about earlier, and that very important screw that has a hole drilled in the end with a counter hole drilled on the back side. That's our low pressure sensing line, as we've discussed earlier, and that's how that water gets up through the stem and through here. Relief valve springs will come out next. Now, here's where we're going to see some differences. Side, over here. Now the old version, the leaded version, the guide was bronze. The stem would come out in one piece like this. The nut on top would come off. It should have only been hand tight, which tells you that there's an O-ring seal. And the O-ring seal was molded into the rolling the bell frame right there. And our friction washer right there. And our guide with our guide O-ring. The newer version, the lead-free version, has a stem, very similar, but you'll notice that our guide is plastic. We have that same O-ring we have here that mounts it, the stationary guide into the body, but we have a little bit different mechanism to roll that bellow frame. One of the problems with the old design, as we talked about, was getting the roll on that bellow frame and making sure we don't twist it when we put the body back in. So there were issues with not only rolling the bellow frame into the body, but maintaining that roll. So in the new version, what the Febco engineers came up with was a retaining washer and this forming washer. I say forming, meaning that it would form the roll into the rolling diaphragm.
So it facilitated that roll like this. So the other one we had to put it in here, roll it in place and put the stem in. This one we put the rolling form in place and holds it into the body. So a little easier for maintenance reasons. And here's our guide and guide O-ring. So reassemble is going to be just the reverse. If you remember the old style, we had to get our rolling diaphragm in place. Like so. Had to get our nut and our friction washer, making sure the rolling diaphragm was all the way in the slot. O-ring was molded inside. We have to make that tight, since it was sealed by a seal in that O-ring on the back side of the rolling diaphragm. Should have been able to get it with hand tight. Then we would take our stem, rotate it back and forth, line it up in place like this, and make sure our rolling diaphragm move easily up and down like that. That was, now for this version, going to be a little easier, because now we have this piece to make our roll. So rolling diaphragm is going to come like this. We can roll it like that. Go ahead and form it with our little guide, putting it in place. Our retainer washer on top. 4 screws. Hold that washer in place. So that makes it a little easier to get that rolling diaphragm folded in place, where your repair technique was critical on this version, the older version, to make sure it worked properly. The newer version is going to be a little easier to get that roll in place. So once we get these 4 screws in, we want to tighten them down, make sure all 4 are tightened, and tighten them evenly across, making sure we have that properly sealed into that guide. Now, taking our stem from the back side, a little easier that way to put it back together. Now, relief valve spring goes on next on both of them, but we still have on both of them have that diffuser plate. And that diffuser plate is important, as we mentioned, that it's pointing up against the stainless steel spring retainer. And here's a lot of close-up I want you to see of that bolt again, because that's a very important part of this particular design, is that bolt. That little screw has that hole drilled right through the center, with the counter hole drilled on the top right there. And that's how that water comes up from the inlet of that guide assembly through here, up through the center of the stem up here, and across here, across that diffuser plate, pushing the water in those 4 veins like that. So let's go ahead and compress the springs. Start with the old style. Oops. Again, when we tighten that screw, we want to hold back on that spring retainer so we don't twist below. And the new style. We have less twisting issues, but we still have twisting issues. So we don't want to just abandon our technique of making sure that that lower rolling diaphragm doesn't twist. So same thing, as we get to that last part of that screw coming down to that last part, we want to hold back on our spring retainer, making sure that as we tighten the screw, we hold back on the spring retainer, making sure we don't have any twisting action through here. Disc retainer, disc retainer. So you can see the differences between the old style, the new style, the lead-free version and the leaded version. Let's go ahead and put this one back together now. Reassembling, making sure we have our guide. Again, it's a blind assembly, but you have to hit the center of that seat. You can look from the bottom through the relief valve discharge, looking down inside and making sure you have that stem, because it has to be right in the very center. It is possible, unfortunately, to get it off in crooked like that, and you don't want that to happen. You're going to break things. So make sure it's dead in the center. You can't observe it from the relief valve discharge, because obviously this is attached to the body. You don't get to look in the back side like this. Put our tab back over our screw, making sure so our screw doesn't embed into our rolling diaphragm. Now our diaphragm on the top, again, has a molded ring on the back side, so it seals easily on the back side. And relief valve discharge is there, so the cover goes this way. And go ahead and get our body cover bolts back on. And a couple other features, in case you're wondering what they are, is this little screw here. There is a screw on the top that allows you to drain the high pressure side of the relief valve body. And there's a plug, a screw on the bottom side here, which allows you to drain the low pressure side of the relief valve body in case you have to drain it for winterizing. The old one had it too. Here's the old version, which had a screw on the bottom, and there was a screw sitting right here. So this is the new style of relief valve in the LF versions of the RP assemblies. LF meaning 860, LF 880, reduced pressure assemblies from Febco, commonly called the Master Series. And the relief valve, as I say, was to replace the leaded bronze, went to ductile iron body, improved a little bit on side of the bellow so that we could see what, easier with our twisting action. We still have to be careful because we don't want to twist that, because that will change that relief valve opening point. And that's our relief valves.